Okay, so in this example, we're given vector b in terms of its xy components as 3 in the I minus 5 in the little j, and we're asked to express this vector in terms of its capital X and y components. And so the way I'm going to do this is I'm going to project, as I've shown here in the lines, the little I and j components onto the big I and j components, and we'll use the net result to get the answer we seek. So with this in mind, what I'm going to do is I'm going to note that the vector b is currently given by 3 in the I minus 5 in the j, and we want to express this as something in the cap I plus something else in the cap j. Let me make that clear here, plus something else in the cap j. So to do this, I'm going to try to express the I, as I said, in terms of cap I and cap j, and so with this in mind, I'm going to write this as the cosine of 36.87 degrees in the cap I, plus the sine of 36.87 degrees in the cap j, and I'll note that little j is equal to minus the sine of 36.87 degrees in the cap I, plus the cosine of 36.87 degrees in the cap j. Now the thing to keep in mind is that 36.87 degrees is the interior angle of a 3, 4, 5 triangle, which means I can rewrite this as little I is equal to 4/5 in the cap I, plus 3/5 in the cap j, and that little j is equal to minus 3/5 in the cap I, plus 4/5 in the cap j. And so if I want to evaluate the vector b now in terms of this new coordinate set, what I can say is b is going to be 3 times I, which is 4/5 in the cap I, plus 3/5 in the cap j, minus 5 times minus 3/5 in the cap I, plus 4/5 in the cap j. And so if I expand this out, I'll have 12 over 5 in the cap I, plus 9 over 5 in the cap j. Minus and minus will cancel, so I'll have plus 3 in the cap I, and then I'll have minus 4 in the cap j. So if I work this out, I'll have 12/5 plus 3, which sounds to me like it'd be 27/5 in the cap I. And I'll have 9/5 minus 20/5, so I'll have minus 11/5 in the cap j. And I'll let you go ahead and work to verify that answer. Best of luck.